Before we start with logarithm, let's have an idea on what we call the standard form. Whenever we say represent a number in standard form, then what we are saying is we want the expression in k times 10 raised to the power x. Before anything, we should know that this k over here should be a single digit. If it's a single digit, then we can say that k should be greater or equal to what? 1, and then it should be less than 10, or it should be less or equal to 9. So k shouldn't be a double figure. So whenever we have any figure at all, let's say 49, then we are going to change this 49 into a single what? Digit. We are representing 49 in standard form. Now, changing this into a single digit, then we are going to have a point. We will bring a point after the first number, where we are going to get 4.9. Now, with the 4.92, we should notice that we moved a point. This 49 is the same as what? 49.0. We move this point to this place. That is how come we are having what? 4.9. So since we are having 4.9, how many times did we move the point? We moved it just once. Since we moved it just once, then that is where this x comes in. We are going to have 4.9 times 10. How many times did we move it? We said that we moved it what? We moved it once. And then moving it once, which position did we move it to? We moved it to the left-hand side. If we moved it to the left-hand side, then the number here should be a positive number. But if we have another example like 0.35, and we are changing this to standard form, we will move this point here from this 0 to behind the 3. We moved it once, but this time around we moved it to the right hand side. So we are going to get 3.5 now times 10 raised to the power. Now where did we move it to? The right hand side. Remember, left hand side positive exponent, right hand side negative exponent. So since we moved it here, we have negative what? 1. And then if you check these, 4.9 times 10 raised to the power 1 is the same as 4.9 times 10. It's going to give you 49 at the end of the day. And then this is going to give you 0.35 at the end of the day. So we are just represented in standard form. So this is what we call the standard form. With these examples on the board, you are going to solve the first two, then you try the last two by yourselves. So with the first one, we have 6,276. And then we are changing this to standard form. Changing this to standard form simply means that first thing first, we should notice where the point is. There is no point in this figure. That means the point is at the last part. Any number without a point in it is having the point at the last digit. So since the point is here, and we are supposed to make this a single digit number, then we move this point to the left hand side. 1, 2, 3. Now the point comes here, where we are going to have what? 6.276 multiplied by 10 raised to the power. Now, as I said, if you move to the left hand side, our exponent of the 10 becomes what? Positive. And then if you move to the right, it becomes negative. Now, how many times did we move? We moved 1, 2, 3 times. Since we moved 3 times, then this is going to give us 10 exponent what? 3. Now let's take the second one, where we have 0.072. 0.072. This time around, we have the point here already showing, and we are supposed to make it a single digit number. Therefore, we move the point 1, 2 behind the first digit. So we are going to have what? 7.2. These zeros are not necessary to write. So we have 7.2. Since we have 7.2, how many times do we move? 1, 2. And then which position did we move to? The right. So 10 raised to the power negative 2. So always remember, the left-hand side is going to give us a positive exponent. And then the right-hand side is going to give us a negative exponent.